Hello and welcome to the first virtual session of the Microsoft Epic program. We're going to be looking at artificial intelligence and the engineering design process. Before we get into that, I want to give you a little bit of an introduction to who I am so you can get a sense of how I approach learning. And I draw a huge distinction between learning and education. I think education can often be boring, it's prescriptive. I think some of the smartest people out there don't really enjoy school, and that doesn't mean they don't like to learn. So what I want to do is give you a sense of my background. My name's Caesar Wright. I taught in the School of Engineering at Rice University for many years. I also work with Microsoft developing programs for K-12, higher education, and community workforce development. And that's a long way of saying that I believe very strongly that education is the key to figuring out how you can transition from your passions into a career in a way that really embraces the uniqueness of who you are. And as you can imagine by looking at me, I've had a very unconventional life path. And when I went to college, I didn't really understand how college worked. I didn't like high school. I didn't like going to classes. I intentionally got thrown in detention every week because if I went to detention, they would give me all of my assignments at once and I could complete them at my own pace and then do other things that were more interesting for me. So once I got to college, though, that all changed. I ended up finishing 3 degrees at Rice University as an undergraduate, went to one of my graduate programs at University of Southern California, and then finished my PhD at the University of Rochester. And so I loved college. And the reason is that in college you could really figure out what it is that's interesting to you and figure out how to connect that to learning. And that's what I want to do today is sort of help you do that, but also in a way that connects to emergent technologies and particularly some of the technologies that are going to be changing society and the workforce that you're going to be entering, which around 65% of the jobs that you will be entering once you graduate high school and college have not been invented yet, which to me is really exciting because that means that you're going to be able to sort of create your own path, which to me is much more fun than following a path that somebody else has set for you. It's also more challenging. It means it's a higher level of responsibility. You have to be better prepared. You have to take risks. You have to spend time finding things that really speak to you. So for me, that was video games. I love video games. I grew up, I lived in a place called Cut and Shoot, Texas. I didn't have a lot of money. We didn't have enough money for computers, certainly. So the only way that I could play video games was if I learned how to create, build a computer. So I had to learn software and hardware in order to build a computer. I didn't really care anything about computer science. I just wanted to play video games. And the only way I could do that is by learning the computer science that would make that possible. So I also think, a lot of parents ask me, what is the one thing I could do to give my child an advantage in applying to top-tier universities? And we're talking about MIT, Rice, Stanford, Harvard, the sort of top-tier elite universities. And my answer may surprise them. I have 2 answers to that question. One, as you can tell by my t-shirt, Brazilian Jiu-Jitsu. I believe strongly that personal security, the ability to feel confident being who you are, the ability to defend yourself and to have that sense of personal security and confidence is huge, because how are you going to join the chess club or the robotics club if you're afraid of getting made fun of or tormented by bullies? And so I believe strongly in Brazilian Jiu-Jitsu. I've worked with the Gracie family that created Brazilian Jiu-Jitsu for many years, and that is the number 1. Number 2 is gaming. I believe that games are an essential acculturating vehicle, is the phrase that I'll use, to training you in the types of next generation skills that you're going to need to compete in high performing teams in industry. And here's why. When you play, so let's take Fortnite. When you're playing Fortnite, what are you doing? You're competing with a group of like-minded individuals to execute a complex task under conditions of limited resources, and you've got time constraints. You have to do risk management, project management, and you have to deliver on a particular result or outcome. Any recruiter you talk to that works for a major company is going to tell you that is an invaluable skill set that they wish every one of their engineers had. So I think that multiplayer online games in particular are a huge learning tool, and I think that a lot of the lessons you can learn if you approach it properly are things that you can translate to all other aspects of life. So that said, I want to talk a little bit about a few of the emerging technologies that you're going to see in industry right now. Augmented and virtual reality, which we have another Microsoft Epic track in that area. Esports and gaming, which obviously you can imagine is important to me. Robotics and drones, which I created another program called the Microsoft Drone Academy that focuses on autonomous vehicles and robotic technology. But underlying all of those systems, I think you're going to see a thread of artificial intelligence. The more sophisticated our robotics become, our computer programs become, our entertainment becomes, the more you're going to see artificial intelligence woven through all of it. So we're going to talk a little bit about artificial intelligence today. I'm going to begin with an overview of what is intelligence. You know, when we talk about artificial intelligence, let's first determine what is it to be intelligent. So intelligence is the ability to learn or understand or to deal with new or trying situations. In other words, to reason. The ability to apply knowledge to manipulate one's environment or to think abstractly as measured by objective criteria. So you'll notice the ability to learn or understand, that's different than the ability to memorize facts, right? So again, I'm not a huge fan of standardized tests. I don't think that they are a realistic measure of someone's intelligence or their capacity to learn. I think that those tests just sort of determine your ability to memorize information, which there's a filmmaker named Werner Herzog that once said that if you read the entire phone book, you will have ingested a lot of facts. You'll have seen a lot of facts. But you're no closer to the truth at the end of the phone book than you were at the beginning. And what he means by that is that to really learn and understand our world, it's more than just memorizing facts. To me, that is really essential, and that's something that I hope that everybody takes away from this lecture. So when we're talking about intelligence, we're talking about the ability to learn or understand, deal with new, and I emphasize new because it's the ability to adapt to new situations as they arise. Not just to learn how to do something and then under perfect laboratory conditions you can always do that exact thing and it functions the same. That's great. That's a useful technical skill, but to me that's less important than your ability to adapt to new information. So when we talk about, a second definition is the ability to think abstractly. And what that means is essentially not just to make decisions based on the facts that you have at hand, but to be able to think beyond those facts. What are the relationships between them? How do they interface with the world? What are some other considerations that might not be reflected in those facts? And then to assimilate all of that information and make more informed decisions. That's crucial. Now, artificial intelligence, there are two leading definitions. I promise I'm not just reading definitions for the sake of reading them. There's an important distinction. So one definition is the ability to, the simulation of intelligent behavior in computers. Simulation is the key because simulation is not authentic. You can dress up as a firefighter for Halloween. It doesn't make you a firefighter, it just means you're good at simulating, sort of looking like a firefighter. But if I've got a fire at my house, I'm not calling somebody that is dressed as a firefighter. I want the actual fire response team to show up. Now, the capability of machines to imitate intelligent human behavior, to me, that's more interesting because that's where we get into real learning. So imitating intelligent human behavior means the computer has the ability to assimilate information and make new determinations based off of that. So moving forward, there are two essential types of AI. There's weak AI and strong AI. A weak AI system relies on algorithmic and programmatic responses to simulate human intelligence. The reason that's important is that no actual learning is taking place. An example of that might be Alexa. If I tell Alexa, hey Alexa, turn on my lights, it's probably going to be able to accomplish that task. Alexa doesn't understand why I want the lights on. It doesn't understand what time of day I need the lights on based on my behaviors. It just understands that I've given it an audible command, which it translates to a quantized waveform, which if you've ever seen them sort of look like this. And that waveform then translates to a computer command that activates the lights. So it's a very prescriptive pattern of behavior. No real learning is taking place. But what's happened is that Alexa is simulating human intelligence. When we go back to that original definition, it appears to be acting intelligently. That is less interesting to me than if we think about a stronger AI system, which we'll get into in a second, which actually imitates human behavior. The thing with weak AI is it may appear convincingly intelligent to users, but it's actually just programmatic. No actual thinking occurs. It's the main takeaway. When we think about a strong AI system is able to mimic the human brain, and the way it does that is designed to be cognitive. It uses machine learning processes. It's designed to recognize context, nuance, not just literal intent, but actually to make determinations on its own based on the information that you've given it. So you don't have to necessarily tell a smart AI system to turn on your lights. It would begin to recognize, like the Nest thermostat, it would recognize from your routine behavior when it wants to make those determinations, and it might ultimately turn the lights on for you, turn the air conditioning up and down. It learns and adapts. It assimilates new information, and it's capable of making decisions with incomplete information. That is a skill that is critical in an AI. It's also critical in a human being. If I'm a company and I'm hiring an employee, do I want somebody that just knows their academic content? And for instance, if it's an oil rig and I'm hiring somebody to maintain the valves on that oil rig and make sure that nothing explodes, do I want somebody that can just read the valves, take the readings on the valves and say, well, this is sort of within parameters or not? Or do I want somebody that can recognize aberrant behaviors? Maybe this gauge, which normally goes up past 30 during regular operations, then it comes back down to 30, but it's been stuck at 30 for 2 days. That might tell me that, you know what, maybe that gauge is malfunctioning because it shouldn't be staying at 30 psi consistently. That's an aberrant behavior. I'm going to recognize that and respond to it. I want that ability in a human being, and I also want that ability in a strong AI system. So let's look at some examples in a second. But first we're going to talk about a phrase you've probably heard, which is, what is machine learning? A lot of these, whether it's artificial intelligence, machine learning, these are things you've probably heard of and you may not know what they are. Even a lot of the people that I know at Microsoft who work in these fields, their job is to wake up every day and code AI systems, and they have a difficulty sometimes explaining what exactly that means. So machine learning is essentially a type of AI process. So you have an AI system. Within that you have these subsystems. One of those subsystems is typically going to be a machine learning process that basically takes in information, looks at available data, looks at previous historical evidence, things like that, and it anticipates an outcome, and then it makes some determination based on that, right? So I gave the example of Alexa earlier, but now let's think about the Nest thermostat. The Nest thermostat is going to use some basic strong AI, and it's going to use some machine learning to recognize patterns in your behavior over time. So if every day I typically get up and I go to work at 9 and I come back at 6 and then I stay home and watch Netflix until 9 o'clock or 10 o'clock and then I go to bed. It sounds boring to me, but maybe that's my life. And the Nest is going to begin to recognize that, and it's probably going to turn off my AC when I go to work. It's probably going to start turning it on an hour or so before I get home, so it's nice and cool. It's saving me money. Over time, that Nest thermostat's going to begin to learn from my patterns of behavior, but as I give it more information, it becomes increasingly sophisticated. So, once again, going to my shirt, suppose Tuesdays and Thursdays I go to Brazilian Jiu-Jitsu. So it's going to recognize that on those days, I'm actually gone from my house from, say, 6. I get home at 5. I leave at 6. I go to jiu-jitsu. I come back at 9. And it's going to adjust the thermostat based on my behavior. So that's new information. It responded dynamically and it adjusts to that. A weak AI system is probably not going to have that functionality built in. A strong AI, the more information we give it and the better quality information, the more responsive it's going to be. So that leads us to the next discussion of what are some of the AI systems we see in the world right now. We talked about Alexa, Siri. Here's one that's interesting to me is the Tesla self-driving car. So I want y'all to think about this. Do I want a self-driving car that's a weak AI, meaning it's only programmed to respond to the things that I've already anticipated? It can probably, if I map out a route to the store and I take the car on that route several times and I sort of show it where the stoplights are and everything else, it's going to learn to, or it's going to function very well. But is that sufficient for a smart driving car? Do you think your parents would be comfortable with your safety if the car was not able to adapt to the kind of safety information, changing driving patterns, weather? My guess is, assuming your parents like you, which I'm hoping most of them do, they're probably not going to be comfortable with that, right? They want a strong AI, a system that's going to adapt and learn from the failures of other self-driving cars. It's going to adapt to weather patterns and say, you know what, it's raining today and it's kind of icy, so although the speed limit on this road is 55 miles an hour, we're going to limit the driving to 45 miles an hour for today based on the weather conditions. Those are some of the features I would like to see in a self-driving car that integrate both weak AI and strong AI. Netflix is another example. It applies pattern recognition and millions of data points to predict viewer preferences. A lot of y'all are probably experiencing that right now at home. You're getting bored. You're trying to find new things to watch. Maybe you're listening to music on Spotify. It works very similarly. It begins to look at the kind of things that you like. What do you watch? What do you rate highly? And then it makes predictions based on that. What do you think are some problems with that? What are some problems you've identified at home? I'm going to pause for a second and let you think. For me, a big problem is sometimes other people in my house use Netflix. And so things come up that I would never in a million years watch, but other people in the household enjoy watching those. So then it throws off the overall algorithm, and now it starts recommending yoga classes and all kind of things that I'm just not interested in, right? But that occurred because it didn't have enough data and it had bad quality data. It didn't have enough data on my preferences and it had aberrant data, bad quality data that threw off that algorithm. Spotify does the same thing. Once again, as you can probably tell looking at me, my taste in music are kind of eclectic. I like everything from reggae to Norwegian death metal. So Spotify, sometimes, because I love Alice in Chains and Guns N' Roses, Spotify thinks I like AC/DC. I hate AC/DC. It sounds like somebody gargling glass to me. I just hate it. But Spotify keeps thinking that I'm going to enjoy it, so it throws it in my feed, and I keep kicking it out, but it always ends up back there somehow. So there's some problems with some of those systems. And notice I'm starting to mention problems. The reason that I'm mentioning problems is because when we identify problems, then we look for areas of opportunity. So for some of you future engineers, the problem that I just mentioned, I would love it if you could fix Spotify so that it never recommends AC/DC again. I will pay you personally. Email me. I'll send you a check for accomplishing that. Drone technology is another good one. We're going to see increased use of drones. Now, do you think we want drones to have a weak AI or a strong AI? Probably a little of both. I want the drone to be able to perform prescriptive functions like determining where did it take off from, so that if it loses connectivity, it can fly back there and land safely and not crash down into a crowd of people. But I also want drones to have some smart AI or some strong AI to be smarter in making determinations about like recognizing wildlife and being careful to avoid birds and things like that. So these are some of the systems that you're seeing right now that are integrating both types of AI. Nest we already discussed. So moving on, I've sort of alluded to this, but we're going to go in more detail now. Quality and quantity of data are the most important factors when you're considering how do we train an AI system. And by training the AI system, what I mean is that once computer programmers develop the AI, so they've created it and it's functional, it is essentially useless until they begin to feed data into that AI system. And I'll give you an example. So Microsoft has an amazing project with snow leopards. So they're supporting a project that helps to identify snow leopards and use cameras in areas that snow leopards proliferate, and looking at migration patterns, looking at population density, and trying to make some determinations about things we could do to preserve snow leopards in their natural habitat, which I think is an awesome initiative. The problem with that is, first of all, no two snow leopards look alike, and all of them look very similar to other kinds of creatures. They look more similar to large cats, right? They look vaguely similar in a really blurry image, maybe to one of my German shepherds. But I'm much less interested in information about wolf habitats if I'm studying snow leopards, so I want to make sure that the AI can reasonably tell the difference. And the way that they achieve that is they plug in millions and millions of images as reference data points to help the AI better understand what is a snow leopard, and are we sure this is a snow leopard and not a mountain lion? Are we sure it's a snow leopard and not my dogs Ragnar and Grimlock? They're got loose and they're running around pretending to be snow leopards. We want to make sure that the AI is capable of making those distinctions, because then we can allocate environmental resources, scientific resources, and we can work on trying to help those animals in their natural habitat. So that's one example that I really love. The important thing to note is that it's not just the quantity of the data, it's also the quality. So if I give it millions of data points, but hundreds of thousands of them are wrong, say I throw in a million images of what I call snow leopards, but 100,000 of those snow leopards are actually jaguars or other large cats, that system is going to fail in identifying snow leopards because I've given it poor quality data. So that's another key that we want to think about. Anytime you're training the AI, we want a lot of information and we want good quality information. These things didn't exist when we were kids, so you're able to have access to much larger amounts of data that are being aggregated from Twitter, Instagram, Facebook. If I wanted to develop an AI that would give you, I don't know, information about the trendiest haircuts right now, I could probably pull a lot of data from Instagram and with a fair degree of precision determine what some of the most popular hairstyles in the country are. Clearly that's not relevant to me. But if I was interested in that, I could do that through all of that social media data. I want to transition now into thinking a little bit about engineering design process and human-centered design. Every single student that came into one of my classes at Rice University, the first thing I told them was, your job as an engineer is to make somebody's life better, happier, safer, or more fulfilling. If you fail to do that, then you failed in your mandate as an engineer. And one of the reasons I love working with Microsoft is that Microsoft's core mission is to empower every individual and organization to achieve more through technology, which is really powerful. And that's just another way of saying to make people's lives better, happier, safer, more fulfilling, to use technology and leverage that technology to accomplish those goals. And for any of you that want to be an engineer because you think, oh, I can make a lot of money, yeah, you can. Absolutely. You can make millions of dollars as an engineer, potentially billions. But I don't think that's the right reason. It's a reason, it's certainly a consideration, but I want you to leave this session recognizing that there are two really strong reasons to focus on STEM and engineering. One is, like me with computer games, STEM can help you connect your passions and what you would otherwise be doing for fun and turn that into a really viable, lucrative career. So that's one. And more importantly, going back to that mission, the Microsoft mission of empowering people, as an engineer, you can turn your passions into products that enhance people's lives in revolutionary ways. When we think of things like the advent of the internet, metallurgy, all of these engineering feats that have occurred over thousands and thousands of years of human history, try to imagine your life today without the internet. That's probably hard for you to do. And for somebody like me, when I was your age, it would have been hard for me to imagine my life with the internet. That's how quickly society is transforming. One of the critical aspects of the engineering design process, we're going to go back to the model in a minute, but I want you first to think about value proposition because it all begins here. If you're creating a product, right? If somebody asks me to create a product but there's no audience, there's no need, it doesn't fix a problem, then what's the point? Why should I create that product? It's just gratuitous, which to me, gratuitous is the other four-letter, non-four-letter word. I don't like gratuitous. I don't like things that are just done just because we can. Doesn't mean we should. I always like there to be an end game. Maybe that end game is kind of frivolous. Like for me, a lot of the things I do are frivolous, but there's always an end game. So I want to return to engineering design process, and we're going to talk through this. Some of you are already familiar with this, but as we talk through it, I want you to think entirely about value proposition. What are the problems that we're trying to solve? So engineering design, we define the problem, we identify the constraints of the problem, we brainstorm potential solutions, we select the most promising solution, we prototype that, we test the prototype, and then we sort of go back to the beginning. We reiterate that until we get to a functional design that we're convinced meets the conditions of our value proposition. When we're looking at this, there's one thing I don't like about this chart. There are a lot of these kind of charts out there that provide an overview of engineering design. The thing that I don't like about this is that communication is left sort of up here at the end of the process, as though you do everything else and then you communicate your solution to the customer and they're happy with it and they move on. Communication really should be in the center here, because when you're defining the problem, you need to communicate with stakeholders. You need to figure out from the people that this actually impacts, what are they thinking about? So you have to communicate there, right? You start to identify the constraints. You need to be talking to content area experts, because presumably if you're developing like a new aircraft for Boeing, you don't know about every subsystem of that aircraft. So in order to determine the constraints, you need to be talking to a lot of people, which requires strong communication skills. When you're brainstorming in isolation, just an army of you, is not terribly effective. You need diverse perspectives. You need people with different points of view, different skills, different education. You need to bring all those people together and communicate with them. And the same thing as we're prototyping, testing, iterating, developing. So I just want y'all to take that away, that this is a good overview, but let's position communication always at the center. So when we're brainstorming, we need to first identify problems. And the biggest problem on everybody's mind right now is, how do we adapt to the COVID crisis? And for those of you wondering, I'm coughing a little. No, I don't have COVID. I just have bad allergies and I have big trees in my yard. So forgive me, but no, I will survive at least through the end of this presentation, hopefully. So we want to start thinking about identifying problems. And if I look at those in the context of COVID, here are a few that I've identified. Survival resources, food, medicine, clearly toilet paper, right? That wasn't a huge concern for me as it seems to have been for a lot of people. I'm good, but this guy apparently was really thrilled to have found a stash of toilet paper. So there are different priorities for different people. Connectivity for business. A lot of people are trying to figure out how do they stay connected, virtually. And that's what I'm doing right now with this. Normally I deliver this presentation exclusively to a live audience. I have always avoided working virtually because I would much rather be sitting with you in a room and looking at your face and sort of talking through this with you, fielding your questions. I would prefer to do it that way. But we don't have that ability right now. So thinking through connectivity solutions, and I would love to find a way to be even more interactive and engaging with the way that we're delivering this session. One way we can do that is through Microsoft Teams and having you join those live sessions and ask questions. There's Zoom, there's these other solutions, but I think engineers probably right now are working on some very innovative ways that we can be more connected, and so my presentation will be less boring for you. When we're talking about entertainment in isolation, I think that's a new realm of where we could think of how to apply AI. Once again, I talked about Netflix and Spotify. I think there are other ways that we can apply AI in entertainment, especially talking about virtual reality and gaming. If you can't leave your house, imagine if we had an immersive world in VR. Maybe use Minecraft VR, right? But what if we could add a higher degree of artificial intelligence to the avatars, the NPCs, non-player characters and avatars in Minecraft, so that they could basically simulate some of the role of people you would interact with in society. I think that would be more fun. Online learning, accurate information, making sure that we have access to accurate information. That would be a really great application of AI. Laws and restrictions. This to me is crucial. There are a lot of you who say, you know what, I'm interested in STEM, but I don't want to be an engineer. Maybe you could be a lawyer, like one of my uncles who was an environmental attorney. And he started as an environmental engineer, became an attorney because he was more interested in the law around engineering than he was the engineering itself. So with COVID, understanding what are all the laws and restrictions, that's huge. Research and prevention. So I'm going to give you an example based on this. How could we apply AI to think about stopping outbreaks of COVID even before they begin? It's one thing to treat something, right? We go to we send people to the hospital, we have respirators, we do all these emergency services to try to treat people. And I think that's amazing. But I'm much more interested in preventing something. If I gave you a bucket of marbles, would you rather avoid spilling the marbles, or would you rather pick them all up and put them back in the bucket? I would much rather avoid spilling the bucket of marbles to begin with. So that's what I think we should be looking at when we're thinking of solutions for stemming the tide of the disease, is how could we use artificial intelligence to recognize potential outbreaks, recognize factors that contribute to the spread of the disease. And here's one that occurs to me, so I'm going to go to the next slide. What if we use a cloud and crowd-based or sourced social media data to identify patterns in the spread and origination of COVID? So by that, what I mean is, imagine if we used information from Twitter and Instagram and we looked at situations where people have used the keyword sick, right? Well, there are two different uses of that word. What if I say, I went to this restaurant and now I'm feeling sick, maybe I have COVID? That's a possibility. Another possibility that you probably might see on social media is, I've been eating nothing but ramen noodles for the past 2 months and I'm sick of it. They use the same word. I'm sick, it's relating to food, But by applying machine learning and a strong AI system, we could start to recognize the distinctions in the vernacular uses of language. And the cool thing with that is that as the language changes over time, uh, we can continue to use that AI, and the AI will adapt with the changing language. So I'll give you an example. What's something that's sort of relevant and timely that came out immediately after COVID that didn't exist before COVID? Pause for a second for y'all to think about that. Tiger King, right? So I'm sure you're all terribly over Tiger King by now. But this is a good example, and here's how I'm going to tie it in. You're probably wondering, what does this have to do with anything? Here's how. If we look at that AI that looks at social media data and looks for mentions of certain keywords and then traces it back to the source. So if they see that 28 people that all ate at this particular restaurant all used the word sick in their Twitter or Instagram feeds, then that might tell the CDC, hey, we need to go check out that restaurant because that's a potential source of the outbreak. Similarly, what if there were an act of bioterrorism where you heard about the tigers at the zoo that were infected with COVID? Obviously we don't believe that was intentional, but there were a lot of memes going around saying, you know who gave that tiger at the zoo coronavirus? Carol Baskin, right? Now we understand that that's a joke because in the context of Tiger King, we understand that there was this rivalry and this guy Joe Exotic blames Carol Baskin for everything, and that's a source of memes. So that's become part of the cultural vernacular. We now recognize that as a joke, but if you had a weak AI, it would interpret that data, and if there were hundreds or thousands or millions of people sharing this meme, and it would say, Carol Baskin gave that tiger at the zoo coronavirus, that might be worth flagging the FBI and saying, hey, we need to send somebody to investigate this Carol Baskin because there's a lot of people that believe she infected the tigers at the zoo. Now we know that that's not the case because this is a cultural vernacular use of the terminology. It's a joke, and a strong AI would recognize, going back to that initial definition that I gave you, a strong AI will recognize the nuance and the context of that and realize that, no, okay, we can disregard that, but if we got another complaint saying such and such has been coughing on ice cream at Walmart, and it gives a name, we might want to investigate that because that is not flagged as a joke. So that would be a real life example of how we could use a strong AI with social media data aggregation to actually make some determinations that would help us identify potential outbreaks of COVID without wasting resources looking into things that are unlikely to be legitimate, right? So now that we've gone through the engineering design process and covered some of the fundamentals of artificial intelligence, what I'd like to do is give you an exercise that you can complete at home. Ideally, this is something that you can do with your parents, with your friends, if you got a little brother or sister running around. What I want you to do is to think about a real world problem. So ideally, we're going to brainstorm maybe 5 to 10 real world problems. What are some problems that you've seen in the world? Maybe they're problems in your own life. Maybe they're things you've heard your parents complain about. I did a session for some kids last year, and there was one little boy that was having a really hard time identifying problems. And I asked him, I said, okay, well, so what are some problems you've encountered? And he said, I don't really have any problems. So, oh, well, that's cool. What are some problems your parents have encountered? He said, yeah, they don't really complain much either. I don't think they have any problems. And I just asked him, can you adopt me? Because that would be awesome. I would love to just go through my day, no problems. And that's the ideal, right? But for me, I'm more reliant on mitigating problems and finding solutions to problems so that I can take them off the table, because I don't have the luxury of just having no problems. So I want y'all to think about, what are some problems that you can identify and what are some potential solutions? Now, when you're doing that, first of all, make sure it's a legitimate problem. So one of the most common problems that I get from students is homework. They say, oh, homework's a problem. No, homework's not a problem. Maybe the types of assignments you're getting are boring. Maybe you don't like doing your homework. That might be the problem. So maybe we need to look at better or different types of assignments for homework. But homework itself is an essential part of learning because there's only so much you can do in school. So that's, to me, like an irrelevant problem. It's not legitimate. Some other things you want to consider as you're identifying problems. Is there already a solution out there that pre-exists? And as an example, how many of you have to make your bed in the morning? Probably a lot of you. I could give you an amazing solution. I would have a NASCAR crew come to your house. They bust up in your room, and in 3.2 seconds, they've made your bed, put all your laundry away, and they're out, right? 3.2 seconds every morning, done. A lot of you probably think that's a pretty cool solution, invasion of privacy and all that aside. But I doubt your parents are going to like that because the price tag for that solution is around $8,000 a morning, so that's going to add up very quickly. Whereas your parents already have a pre-existing solution that's just as efficient, just as effective, and far more cost-effective, which is you. They can just make you make your bed, and they don't have to pay $8,000 a morning. So that's an example of it's a problem, it's a legitimate problem, but there's already a pre-existing solution that's cheaper and that works well. It's not the most technical solution, it's not super sophisticated, but it's functional, and sometimes that's all you need. So when you're doing this, I want you to think about and maybe identify 5 problems, and then draw from your own experiences, identify a prospective target market. This would mean thinking about, is this a problem for anybody other than you, right? Some problems are so specific to you that they may not be relevant to other people. So you're going to have a hard time getting investors or selling that product, right? Does a good solution already exist? We sort of addressed that. Normally, if we did this as a live event, I would have you type your ideas into the chat window. Instead, what I would encourage you to do is hashtag your ideas or your solutions later to AI for good. So hashtag AI for good and see what kind of responses you get from other people. You might be interested to see the kinds of feedback you get from other people. When I do this exercise live with students, typically what I find is that the problems and solutions that you are able to identify as middle and high school students often are directly related to things that they're already developing in industry. Meaning that a lot of you will go through a session with me that's an hour-long session with high school students or middle school students, and you're identifying problems and coming up with solutions to things that people in industry are spending millions of dollars researching, and that's pretty cool. The idea that you could sit down and identify the same solutions as Facebook or Microsoft or Chevron, and you can do that in an hour with a group of high school students. If you take that knowledge and you transition into higher education and industry, that's going to be really powerful. Okay, so once you've identified some problems, and I would say start with 5, think through some prospective solutions. And when you're considering those solutions, think about whether we could apply AI to solving that problem. So there are going to be some problems that lend very well to AI solutions and other problems that don't. And I'm going to give you an example, and this is maybe a challenge, so prove me wrong. A lot of the work that I do outside of my STEM work is on anti-bullying. And I believe very strongly that bullying is a problem that begins with kids and really has to end with kids. I think that a lot of it can be addressed through developing self-confidence, self-defense, the ability to deal with bullies. I think I see a lot of attempts to regulate online interactions between kids, to regulate social media, even to file charges on people based on things they've posted online. I'm not convinced that those are going to be effective solutions. I think that sometimes a human solution is better. Finding a way to help deal with the causes that contribute to why do people become bullies. help kids deal with the psychology of bullying, I think, to me, those are humanistic solutions that are probably more powerful than technology. But once again, I'm wrong about a lot of things. You'd be surprised how many things in a general day that I'm wrong about. So prove me wrong. Find an AI solution that helps to fight and prevent bullying, and I would love to see that. But to me, that's an example of it's a legitimate problem, certainly a legitimate need, but I'm not convinced that AI would be the best solution to dealing with it. There are other things that I think AI is highly effective in addressing. So I want you to consider that when you're going through your prospective ideas. Not just identify the problem, think about is this a reasonable application of technology? Should we apply AI, or is there a better technology that we can apply? And if we do apply AI, how would we apply it in a way that makes sense, that is cost effective, and that truly addresses that value proposition that we identified earlier? And what I'm going to challenge you to do, and this will all be in the exercise description, but what I'm going to challenge you to do is, after you identify your 5 problems, and you vet those and make sure that there is a legitimate market for them, AI is a legitimate solution, potentially, then I want you to map that out and imagine that you are creating a Shark Tank style presentation. And you're going to pitch this to a panel of experts from industry who are going to rip it apart. They're going to look at it and look for every single hole in your logic. Maybe your parents can be those industry experts that rip apart your logic. Some of them will have fun with that. And it's constructive. It's good. We want them to intellectually challenge your ideas so that your ideas become better, and you're better situated to develop a responsive solution in the future. So hopefully we're clear on all of that. You're always welcome to email me or follow up on imstempower.org, and we can give you information about some of our upcoming programs. And I am always interested in seeing the kinds of ideas that you come up with. I would love to see you develop those ideas into a Shark Tank style presentation using perhaps Sway, Prezi, Microsoft Word, some sort of presentation software, and imagine that you are pitching to an investor to get $20 million to bring your idea to life. What would you tell that person that would convince them, first of all, that it's a good idea, secondly, that there's a return on their investment, and third, that you have the ability to sort of bring this to life and make it technically viable? Consider all of that, develop your presentation, and practice delivering that to whoever it is you have access to. Maybe even deliver it online in a form like this. Maybe make a video, or do an online streaming presentation for your teachers, your friends, and once again, reach out, and maybe myself or some of the Microsoft team will even join in on that presentation and participate with you. So thank you again. I hope you enjoy the presentation. Feel free to follow up. I'm going to share some contact information. Follow us online, hashtag Microsoft Epic. imstempower.org is the website where you can find information about this program and others. The Microsoft retail stores offer an amazing breadth of resources and programs in everything from Minecraft Hour of Code, Fortnite tournaments. How to Sharks Swim is a session where they actually look at the mechanics of how sharks swim, which I think is very cool. Sensor design. These are all sessions you can take 100% free. All of my programs, again, sponsored through Microsoft, are 100% free. So stay positive, keep working, and always strive to be epic.